With so many new and novel electric vertical takeoff and landing aircraft being developed, there are numerous safety and regulatory concerns to be considered. These concerns play a role in determining the configuration selection of an eVTOL aircraft to ensure that they are fault tolerant. Fault tolerance simply means a system's ability to continue operating uninterrupted despite the failure of one or more of its components. This is one of the reasons why there are multiple rotors in many of these eVTOL designs, so that if any one motor or subsystem were to fail, there would be several others that can compensate for the failure and still land the aircraft safely. So in essence, the vehicle flight control software should be specifically designed for all of the different cases in which a thruster or actuator is removed from the system. To demonstrate this concept, I will use my small-scale Joby eVTOL aircraft replica to demonstrate what might happen if a single motor were to fail. I'm going to literally cut this motor wire so that this motor no longer works. And then we'll see if we can still take off and still hover. This is very painful, but I'm gonna do it. So we're gonna cut it. Boom. In this case, I have not told the flight controller that I have removed a motor. Instead, I will let the PID controller compensate for this loss with the remaining motors and servos. So as you can see, even with one of the motors completely malfunctioning, the aircraft is still able to hover and fly. So why is this? Well, we can look at a free body diagram to understand the forces and moments at play. In hover, when we lose this motor, we lose some roll authority. Thus, we compensate by giving additional roll authority by biasing it towards the remaining functioning motors. For pitch, we do the same by giving increased or decreased RPM commands. For yaw, we can give additional RPM commands as well as servo commands on the outer two motors. In forward flight, the same principles apply. If we'd like to pitch up and lose a motor, the servo commands can compensate. If we'd like to roll right, we again give increased servo commands that are biased towards the direction of the failed motor. And lastly, to yaw right, we can give additional RPM commands. There are a number of different ways to accomplish this compensation, but the main goal is to decouple the commands as best as possible. Lastly, here's some quick in-flight footage of the eVTOL replica.